Adding and subtracting rational expressions with the same denominator and finding the least common denominator. So adding and subtracting rational expressions with common denominators, if P over Q and R over S are rational expressions, then P over Q plus Q over R is the same as P plus Q over R. Now, this is extremely different from multiplication and division. In multiplication and division, you do not have to have a common denominator. In addition and subtraction, you do. Please remember that. So as long as if you're adding or subtracting, you must have a common denominator. So if the denominators are the same, what you're going to do is you're going to add the tops and leave the bottom alone. So you're going to add the tops and leave the common denominator as is. Same thing in subtracting. You're going to subtract the tops and leave the denominator as is. So to add or subtract rational expressions, add or subtract numerators and place the sum or difference over that common denominator. Once you have a common denominator, leave it alone. Alright, so let's add these. So look at what we have. We have common denominators. Yes, those denominators are groups, but they're exactly the same group. So remember, when you have a common denominator, leave it alone. So we're adding. So we're going to add the tops. Now, to add a binomial plus another binomial, we learned how to do this in pre-algebra. You're just combining like terms. So 4p plus 3p is going to be 7p. And then negative 3 plus a positive 8 is going to be a positive 5. And so your answer is going to be 7p plus 5 over that common denominator of 2p plus 7. Now again, remember we talked about this earlier. You cannot reduce the 7 and the 7. You cannot reduce the p and the p because those are groups. The only way to reduce a group is if you have another group just like it. Same thing with subtraction. So what we're going to do is we're going to combine the tops, combine like terms. There's not any like terms, so we just write down what we see, 8y minus 16 over that common denominator. Now, at this point I want you to notice that we can reduce this problem. So at this problem, we couldn't reduce it, and the reason being is because 7p plus 5 is prime, in other words, it won't factor, and 2p plus 7 is prime, it won't factor either. However, look at this top right here. There's an 8 in common, so if I bring an 8 out, I'm going to have y minus 2 over y minus 2. Now, these two binomials will reduce, and my answer is just going to be 8. Alright, let's look at this one. Here we have common denominators, so we're good. We are subtracting, and notice this minus sign is going to go for this whole entire group. So again, we're going to combine like terms, but don't forget you're subtracting. So 3x squared, there's not a like term, so we're just going to bring it down. And then we have 2x minus 10x, which is going to be a negative 8x. And then we have minus a negative 5, which is going to be plus 5. Don't forget, this minus sign goes here and here. So we have 2x minus 10x, which is negative 8x. And then we have minus a negative 5. Double negatives go to plus. And then we're going to put that over our common denominator of x minus 1. Now here, I have a trinomial. My leading coefficient's not 1. I'm going to try to factor this. I don't know if it'll factor or not, but I'm going to try. So the first thing is I'm going to bring that 3 over to that 5. So multiply 3 times 5 and I'm going to get 15. And then I have to think, we're going to try to factor this. So I'm going to have x minus and x minus, and I have to think, is there anything I can multiply together to get 15 but add together to get negative 8? And so we're thinking negative 3 and negative 5. Oh, I'm sorry, negative 5. Alright, so then we're going to bring that 3 back out, and we're going to reduce where we can. So we have x minus 1, and then this one won't reduce, so we're going to do 3x minus 5. So that's going to be my new numerator. I'm going to have x minus 1 times 3x minus 5. Notice that that x minus 1 group is the same, and so my final answer is going to be 3x minus 5. Alright, so finding the least common denominator, and we're going to use this topic in the next section. So if you have a common denominator, you don't have to worry about this. But to find a common denominator is really difficult, and I wanted to do it here so that when we have to find a common denominator, we'll know how to do it. So to add or subtract rational expressions with different denominators, you have to change them to equivalent forms that have the same denominator. In other words, a common denominator. This involves finding the least common denominator of the two original rational expressions. So let's see how that's done. Step 1, you're going to factor each denominator completely. And then the least common denominator, LCD, is the product of all unique factors found in step 1, each raised to a power equal to the greatest number of times that the factor appears in any one factored denominator. So that's a mouthful, so make sure you read through that and make sure you understand what it says. The least common denominator is the product, the multiplication, of all unique factors. In other words, you can only use things once and only once that we found when we factored out at the very beginning, each raised to a power equal to the greatest number of times that the factor appears in any one factor. In other words, you're going to use your highest exponent. Alright, so let's look at this. It says find the least common denominator of the following rational expression. So we have denominators of 6y and 4y plus 12. So 6y and 4y plus 12. So remember, the first thing we're going to do is factor. This is a monomial. So since this is a monomial, we don't have to factor it. Over here, however, we're going to have 4 times y plus 3. Okay, so what we're going to do to find the LCD is we're going to write down everything that we see once and only once. So I see a 6y, I see a 4, and I also see a y plus 3. And now what I'm going to do is I'm going to multiply any monomials. That's what it's talking about with the highest powered. So 6y times 4 is going to be 24y times y plus 3. And that is your common denominator, 24y times y plus 3. Alright, let's try this one. Find the least common denominator. So what we need to do is we need to factor each one of these. So I'm going to have on the left hand side, x squared plus 4x plus 3. So trinomial where your leading coefficient's 1, so we're just going to open up two sets of parentheses, put a plus and a plus because the signs are going to be the same. Split your x squared and think, what can I multiply together to get 3, but add together to get 4? You don't have much option. It's going to be 3 and 1. On the right hand side, same thing. I have a trinomial. My leading coefficient's 1. Signs are going to be the same. Split the x squared up and think, what can I multiply together to get 21, but add together to get 10? And I'm thinking 7 and 3. Now, to find your least common denominator, you're going to write down anything that's already in common. So look at this. You have the x plus 3 and the x plus 3, but you're only going to write it down one time. So you're going to use everything once and only once. So you have that x plus 3 done, gone and gone. And then we have x plus 1 gone. And then we have x plus 7. Got it. So your common denominator is going to be these 3 binomials. Don't multiply them together. Alright, so now, once we know what the common denominator is, how do we write equivalent fractions? So to change rational expressions into equivalent forms, we use the principle that multiplying by 1 or any form of 1 will give you an equivalent expression. So for example, here I have p over q. Well, what I want to do is I want to make an equivalent expression of p over q. And to do that, I have to multiply by 1. So remember, when you multiply, you can multiply anything you want to together, but to get 1, you have to have something over itself. So we're going to turn this 1 into r over r, because you know r divided by r is going to give you back to 1. And then we're going to multiply these. So p times r is pr, and then q times r is qr. And that's how you make an equivalent fraction, because look, I can take this fraction here, and I can reduce the r's, and that's going to take me right back to where I started from. So that is going to be an equivalent fraction. Alright, so let's make an equivalent fraction out of this one. What do I have to multiply 9y to the 5th by in order to get 72y to the 9th? Well, 9 times what gives you 72? I'm thinking 8. And y to the 5th times what is going to give you y to the 9th? Remember, when you multiply powers with like bases, you add those exponents. So if I have 5 here, I need 4 more to make 9. So I'm going to say y 4. So look, if I multiply 8y to the 4th times 9y to the 5th, I get 72y to the 9th. Well, this numerator I have to multiply by the exact same thing. So look, here's my 1. So I'm going to multiply the top times that. So 8y to the 4th times 3 is going to give me 24y to the 4th. And I can go backwards again. I can reduce this. If I reduce this, that's going to give me 3 over 9y to the 5th.